Hi guys, welcome back to another video. In this video we're going to look at the proof that the square root of 2 is irrational. So this is a very old proof and, well, the way we're going to do it, we're going to do it in quite a simple way. Just requires a few key observations. There are actually many ways to prove this, but this is without doubt one of my most favourite proofs across all of mathematics, and I've seen quite a lot. So yeah, we're going to be proving that the square root of 2 is irrational. Now, what do we mean by a number that's irrational? Well, it's not rational, so that means root 2 cannot be expressed as a over b, where a over b are some integers. And also we have to have this condition that b is non-zero. So this is what we're trying to prove. Root 2 cannot be expressed as the ratio of two integers, basically. Now, how are we going to do this? We're going to do it using proof by contradiction. So I'm going to call that PBC for short. So what do we do when we're doing proof by contradiction? Well, we assume the opposite of what we're trying to prove and then try and arrive at a conclusion that is impossible, basically. So what we're trying to do is show that if root 2 is rational, then it just can't be, basically. So let's do that. Let's assume root 2 is rational. So that means it can be expressed as a over b, where a, b are integers, and b is non-zero. We're also going to assume that this fraction is reduced. So I'll just write that. Reduced fraction. And what I mean by that is that there isn't any common factors in a and b, so that, well, for example, if we have 6 over 12, we know we can take a factor of 6 in both sides, and that comes out to a half. So our a over b is like this, a half. There's no common factors in it. Right, so how are we going to arrive at a contradiction with this? Let's write down our root 2 equals a over b again. What can we do from there? The only thing we can do really is square both sides. So we get 2 equals a squared over b squared. And then what can we do? We can multiply by b. So let's go ahead and do that. And that gives us a squared equals 2b squared. Now recall that if something is, so if we've got 2 times dot dot dot, this is an even number. No matter what the thing is in the brackets, if there's a multiple of 2 outside, it's even. So therefore, we know that a squared is even. And you'll have to excuse my handwriting. I'm not just trying to get used to this pen for my iPad. Right, so we have a squared is even. Let's make another observation over here. So let's suppose, well, there's obviously 2 choices for a. A can either be odd or a can be even. Let's assume a is odd. A odd. So that is, again, similar to this observation here. Just going to change colours here, switch it up. So now we can write a equals 2k plus 1. That's what it means for a number to be odd. So then a squared equals 2k plus 1 squared, which equals, so let's expand this out, you get 4k squared plus 4k plus 1. If we take a factor of 2 out, 2 times 2k squared plus 2k plus 1. So what have we done here? We've actually shown that a squared is odd if a is odd. So this is a contradiction. And from that we must be able to deduce that a is odd. Sorry, a is even. My bad there. Well, we've shown a squared is odd here. So that's a contradiction there. So let's forget about that for now. So we've shown that if a squared is even, then a must be even. So what does it mean for a to be even? Well, it means that a equals 2m. for some m in z, some integer m. So we have that. What can we do with that now? Well, the only thing we can really do is substitute it back in here. So let's go ahead and do that, and that will give us 2m all squared equals 2b squared. Let's carry this on the next page. So this gives us 4m squared equals 2b squared, and rearranging for b squared we get b squared equals 2m squared. Now let's use a similar argument to before. We can now see that b squared is even, as it's of the form 2 times something. So there we go, we have b squared even, and then by the exact same argument here, we must have that b is even as well. So that's that. And then that tells us that b equals 2 times n for some n in z. Let's switch colours as we're nearly done here. So now what do we have? We have root 2 equals a over b, and this was in reduced form, remember, so you can't cancel a over b down any further, but we just worked out that a equals 2m and b equals 2n, but then the 2's are going to cancel and we're left with m over n, and this is a reduced fraction here, which is impossible, and that is our contradiction there. Contradiction as a over b was reduced. And then, as we have a contradiction, it must mean that our initial assumption was false. And what was our initial assumption? Well, that was assuming that root 2 equals a over b, where a being integers and b is non-zero. And because of that, and because of this contradiction there, we must have that root 2 is not equal to a over b, and therefore root 2 is irrational. So messy handwriting aside, I hope you enjoyed that video, guys. Stay tuned for the next videos. I have a lot of plans for this channel. Thanks for watching. Bye bye.